alternating current through a pure resistor. Whenever the alternating current flows through the pure resistor, so what all the things is going to happen? For that, let us consider a simple circuit which consists of a pure resistor R which is connected across the voltage. So this is the circuit. So a simple resistance R which is connected with the voltage. Then, so let us write the equation for the voltage. So your V is given by Vm sine omega t. Since it's a alternating current, so the voltage equation what I want to get, it will be in terms of a sine. And from the Ohm's law we know that I will be equal to V by R. So it is given by Vm sine omega t by R. So what is Vm by R? So we know that Vm by R will be nothing but Im. So we can write Im equation as Im sine omega t. So from this we can get the equation for V as Vm sine omega t and I as Im sine omega t. We can observe in both the cases, along with sine we have omega t, here also along with sine we have omega t. Means if you compare with both voltage and the current, along with omega t we don't have anything. So the angle will be 0 in both the cases. So if you take V as a reference here, right, since the current equation is also Im sine omega t, along with omega t we don't have any angle, so both your V and I will come in phase. If you write the phasor diagram in pure resistive circuit, both the voltage and the current will come in phase, and your phi will be equal to 0. So we know that power factor, your power factor is given by cos phi. So we know that your cos 0 will be equal to 1. That's why in case of a pure resistance, the power factor will be unity. Next, let us derive the equation for the power. So we know that the instantaneous power P is given by instantaneous voltage into the instantaneous current. So just right now we are derived the equation for V as Vm sin omega t and I as Im sin omega t. Just we are going to substitute that and we are going to try to simplify further. So P will be equal to Vm Im sin omega t into sin omega t will become sin square omega t. So whatever the sin square omega t is there, we can write the sin square omega t as, in terms of cos will be, it will be 1 minus cos 2 omega t divided by 2 into Vm Im. So whatever the denominator 1 by 2 is there, we can write this one as Vm by root 2 into Im by root 2, and the left out will be 1 minus cos 2 omega t. So we know that the maximum value by root 2 is nothing but the RMS value. The RMS value is given by maximum value by root 2. So what we can Vm by root 2 and Im by root 2, we can replace that one by Vrms into Irms into 1 minus cos 2 omega t. Since as your omega t is varying from 0 to some value, so cos of 0 will be 1, cos of 90 will be 0, cos of 180 will be 1, like that it will be fluctuating in nature. So one positive cycle we will get, one negative cycle we will get, so the resultant of that will be a 0. So we can neglect that one, as the resultant of that will be 0, it is fluctuating in nature. So we are going to get the equation as P will be equal to Vrms into Irms. So this is what the power equation what we are going to get for the pure AC circuit. Now if you want to write the waveform for this, so let us consider this. First let us write the waveform for the voltage. Since we have V is equal to Vm sin omega t, when omega t is 0, it will be sin 0. When it is sin 0, anything multiplied by 0 will be 0. So your voltage will be 0. When omega t is 90, so sin 90 will be 1. So we want to get the maximum value. Again at 180, it will be 0. At 270 it will be a negative maximum. At 360 it will be 0. Similarly, this is the voltage equation. Similarly, if you write the current equation, so we got is Im sin omega t, where Im will be equal to Vm by R. So it will follow the voltage, as both are in same phase, but the magnitude of the current will be lesser than the voltage because your I is given by Vm by R. So this will be your current. So this is the voltage and this will be the current. So right now we are doing the equation for the power, which is given by Vrms into Irms. So your P will be the resultant of both a voltage and the current. So here at the initial condition, both will be at 0. 0 multiplied by 0 is 0. Then at 90 degree, both are at the maximum. So your power will be at the maximum. Then it starts decreasing. At 180 it will become a 0. Next, here both are negative. How? The current is also minus and the voltage is also minus. Negative into negative will give a positive. So the power will be positive. It will reach the maximum at 270 degree. Again it will decrease and it will reach the minimum at 0. So here, whether the voltage or the current, whether it's a positive cycle or the negative cycle, whatever the power here we're going to consume, it will be always will be the positive, because when the current and the voltage are in phase, when voltage is in positive cycle, current is also will be in the positive cycle. When voltage is in negative cycle, current is also will be in the negative cycle. So plus into plus will be plus, minus into minus will be equal to plus. That's why in any of these cases, whatever the power we want to get in a pure resistive circuit, it will be a positive one itself.